In this tutorial, we're going to use Fab 3000 to find and prevent probably the most uh, problematic error, and that would be having Gerber drill data files that contain any type of opens or shorts in them. Now, these are the type of things that will pass the DFM and DRC checks with flying colors. However, if there happens to be an open or short in your Gerber files, or even ODB++ or other manufacturing data, uh, you're in trouble. And so by simply using Fab 3000 will show out in just a matter of a few minutes. You can always verify and detect that your data before you send it out for manufacturing is electrically sound and won't have any problems. So the first thing we're going to do here is, typically in most examples we auto load a particular set of Gerber files, drills, or ODB files. I'm going to open up an existing workspace that has a short in it. The idea here is to go ahead and say, hey, if I'm just using a viewer and I'm just looking at my particular Gerber files, turning on layers, turning them off, doing anything else of that nature, are you able to find the short just by looking? And that's one of the most difficult or things to make aware to a lot of users is that, or designers, is just because they've finished their board, they've designed it, laid it out, you've got to spend just a little bit more time to check and verify your Gerber drill data, ODB data, all your manufacturing data, just to make sure, if for nothing else, that there's not any electrical connection problems. Because again, any manufacturer or board shop that you send your data to, they can fix if there's any type of annular ring problems or other little small minor editing things. What's most important is to make sure that the connectivity is good, because without that, your boards are scrapped. Pretty much you've got to start from scratch and you take a loss. And again, just using some type of free Gerber viewer or any type of Gerber viewer just won't do, because this is just a simple, easy old board. Nowadays, things are way more complicated, and it's still hard to visibly see where the short is. So what I'm going to do now is use Fab 3000 to find the short. So what I'll do is I'll go to the Tools menu, and I'm going to extract the nets. What Netlist extraction does is essentially it just takes your Gerber files and reverse engineers them and tries to find out everything that's connected. And by doing that, whatever's touching as far as in the Gerber gets counted as a net, and it goes so on from there. So in this case, I'll just select all the options, click Next, and at this point, Fab 3000 is doing that, is performing the netlist extraction, so it's trying to connect all the data. So it's done that now. It's found 403 nets. It took about 7 seconds. So at this point now, if I click down here in the netlist table, you'll see that all the nets, everything highlighted, shows up here. You can see the net coming all the way down on here. Another nice feature of Fab 3000 is you can actually isolate the nets. So if you just only want to look at one specific net, let me increase the size of this a little bit. It allows you to highlight and zoom in right into the areas where the net is. I personally prefer the shadow because I just like to have the overlay of the nets on top of there. But in any case, you see that Fab 3000 has reversed engineered the Gerbers and extracted the true net list. Because again, no matter what was in your design software that you used, the nets, everything else doesn't matter, because a board shop is going to be going off of your Gerber and drill data. So at this particular case, it's the Gerber and drill data that matter the most. So now now we've finished extracting the net. So what we're going to do now is import an IPC netlist that you would have generated from your CAD tool. Just about every CAD tool has the ability to export an IPC 356 netlist. And so in this case, all you simply do is go Fab 3000, go to the import menu, and you select right here the IPC 356 netlist. In this particular example, I have the netlist waiting in this folder. Click open. And what it tells me is that it's loaded in. There's 1,388 test points, and it gives you instructions of what you can do. As soon as I load this in, you'll begin to notice that there's little marks here, and basically what that is for a net connection at the top, you'll have a down similar to a V, and for a bottom you have an upside down V. So it forms an X if you have both a connection at top and bottom for through holes. This is just a simple board, so everything's through holes. That's why you see the X appearance. In any case, all I need to do now is go to the Tools menu, go Net, and go Netlist Compare. In this case, I'm able to, it gives me a selection of what it can look for as far as finding opens and the shorts. And these two right here are not as really critical as just finding missing copper locations or anything else of that nature, but I'm going to go ahead and select those. But the main thing you're looking for is open and shorted nets. So by clicking next, you'll see that what happened is that even though the board looked good in the viewer and I couldn't really see what was there, the FAB 3000 has actually detected that there's an open and an external net missing. Typically these are related, so you want to go by the open net because typically that's what it's going to be related to. So I press finish, and what happens is now I'm in the browser mode. And so here what it does is it allows me to browse the error. Now finding netlist connection errors in shorts and opens can be a lot more difficult, but using FAB 3000 we can find it by just doing the following. I'll click open net detected. What it does is it highlights and it tells me that this particular net, just by looking at this, has a problem. So I go to CamNet 40. So that's all you're concerned with when you're checking for shorts and opens, is looking for the CamNet. So I scroll down here, I find right here net number 40, highlight it. As you'll see here, here's pretty much my net. It looks fine up here, but if I trace on down here, all of a sudden it looks like it just ends. So why don't I drag and then scroll on in here? And whoa, it looks like here's the open. And I'll go ahead and take this off, and you can see right there. Yep, that's it. That's the open. And this board passes DRC and DFM checks without any problem. However, it's going to fail because it is not electrically sound. And that's typically due to either the way that the CAD program will output the Gerber files, or a whole host of other small menial things that can happen. And so that's why it's always good to just check your Gerber data files before you send them out, and not just run a DFM check, not just view it in a Gerber viewer, but to actually have the capabilities to run the full DFM netlist check. And so again, this is available in FAB 3000. And if you mention that you saw this video, we'll actually offer you a 50% discount for the tool. And if you're watching this on YouTube, right below there should be a discount link for you. Thank you very much for watching.